Hi, everyone. So this is just going to help you get going with Lab 2 and complete that pre-lab assignment for Lab 2. So what we're going to do here with this lab, you'll see in the instructions in more detail, is essentially we're going to collect some data. We're going to, a lot of data. We're going to check out the accelerometer sensor, the force sensor, and the wheel sensor. I'm going to uncheck position because we're not going to really look at that this time for this lab. But basically what we'll do is I'm going to place the device wheel side down on the table, and I'm going to give it a push on the force sensor there. And I'm going to let it roll for a second or two after I'm done, my fingers left the force sensor and stop pushing on it. We're going to look at that data as it's slowing down, or we might say decelerating or negative, having negative acceleration. We'll give that a try. Okay. And so first thing I'm going to do is I'm going to zoom in on all that data. And you guys are going to work on the accelerometer and wheel sensor stuff, but I'm going to show you some stuff with the force sensor. And the point of the force sensors with this is to really help you identify where did the device start moving moving with a constant negative acceleration as it was slowing down after I was finished pushing on it. So since the wheel sensor is along the y-axis, that's all we care about. So you can uncheck everything but that on the accelerometer sensor. And you can see it actually pretty much that the point where where I push on it and let go, pretty well corresponds to the accelerometer graph. So what I'm going to do is I'm going to show you how you already know how to collect some data. So click and drag and we get a whole this information. And so you know the mu is the mean, the sigma is the standard deviation. And we're going to use that in how we report our the data we collect for this lab. So another way we could say mean, you might start seeing this in class, is X in these brackets like this. And so using those two things and one more thing, that's what we're going to need to collect our data. So the other thing we're going to need to know is the standard error of the mean. So it tells us the uncertainty of that mean value. And to do that, we'll take that sigma, the standard deviation, and divide it by square root of the number of data points that we collect. Okay? So in order to do that, we're going to have to export a spreadsheet. So when we look at the graph here, underneath the graph, you'll see each graph has this square with an arrow on it. And when you click on that, there's an export to CSV button. And when we do that, we'll see that it takes us to our documents folder and into a folder called IOLab work file. So when you downloaded the IOLab software, it created this IOLab work files folder in your document folder in order to save your place where to save your calibration and all the data you collect. So we'll go there, and I have a bunch of things in there because I've been playing around, but the latest one is there, and I'll open that in Excel. And you'll see it gives us a bunch of information here. So some of these things is not going to be important for this lab, like the frame and the sample. So I'm just going to delete those. But obviously the time is going to be important because that will help us to identify places on the graph. Now the raw zero and the cal zero, the cal stands for calibration. So the raw is just the raw data the sensor collects. So we don't need that. We need the calibrated data. So this is basically my force data. And over here, our index is counting the number of data points. All right. So it's saying this data point 0 corresponds to this quantity. And that's how we'll actually find n. So when we look at the iLab software, I'll put my cursor over where I started to highlight the data, and we see the time is at 1.865 seconds. So if I scroll down to 1.865 seconds, bam, right there, that was at the 372nd data point. Okay, and then put my cursor at the end of where we stopped collecting data, and that was 3.205. So 3.205 is 640th data point. So I'm going to subtract, I'm going to do 640 minus 372. And that will give me 268. So that means in this interval, there's 266 data points, and that's our n, 268. So we'll take that sigma here, and we'll divide that by the square root of the 268, and that will give us our standard error. And the way we're going to want to report our data is in this form: the mean plus or minus that standard error. And then I'll show you one more thing that's a little different with the accelerometer data when you export that and when you export the wheel sensor data. So let's look at the accelerometer if I export that. And now it's going to give us some of the same things, but instead of ending with raw 0 and cal 0, I now have raw 1, cal 1, raw 2, and cal 2. Okay, and that's because there's three things going on here with the accelerometer sensor. We have accelerometer has acceleration along the x-axis, along the y-axis, and the z-axis. So when we look at this, our cal 0 is the first one. That's our AX. Cal 1 is our AY, cal 2 is our AZ. So just in that same order as how they show up here on the graph. And then same thing with the wheel sensor. It's in the order of position, velocity, acceleration. So position will be your cal 0, velocity cal 1, acceleration cal 2. All right, then just a brief review of what's the difference between random and systematic uncertainty. So the random uncertainty is caused by something we can't really figure out or predict, some sort of changes there. We'll see a Gaussian or normal distribution in this, and sometimes we refer to this as noise. And so we'll particularly focus on this one in this lab. And then the systematic uncertainty is some issue with the measuring instrument itself. So in our case, it would be there could be some sort of issue with the iLab sensor. So for instance, when you go to calibrate the force sensor, it tells you to place the device like this on the table with the hook side up, and then click next. But if you click and hold it like this, and then click next, while it's supposed to be sitting on the table, you're going to totally mess up your calibration. And so that will be a systematic uncertainty. But we're going to look at the noise, the random uncertainty. So we already see that just visually looking at our graphs. We've got a lot of noise here. And so what we'll do here is we'll actually plot this noise. And to do that, on Moodle, you have a link to this normal distribution spreadsheet. And here, you could put in some stuff here. So these two columns, you don't really need to use here if you were just doing everything in Excel already. It's mostly we want to put data here under this deceleration data column. Okay, so we want to look at the noise during the deceleration. Okay, So we already highlighted that in the spreadsheet. Right, where it started, okay, and where it ended. So I'll just collect the actual force sensor data during that time. And I'll copy that into my spreadsheet. And it will calculate the mean, the standard deviation, the density, and then it'll give us our nice, beautiful normal distribution there. Okay, and so you'll do that in the lab, yeah, either with the accelerometer data or the noise in the wheel data for the acceleration, or with the phone accelerometer.